All right, we're going to continue our unit on polynomials. We've touched a little bit on adding polynomials. Today we're going to review that and then talk about subtracting polynomials as well as graphing polynomials and looking at how they behave. So here's our learning targets. What I'd like you to do is give this problem a try, pause it right here, and see how you do. See if you've got adding polynomials down. All right, so how did you do? When we do this problem, you want to drop the parentheses just like it says, combine like terms. I did that in different colors, and then make sure your answer is in standard form. So here, you should get 3x to the third plus 5x squared plus 6x plus 13. Okay. All right. So quickly in math, I want to talk about what opposites are. Specifically, we're going to talk about additive inverses. So in other words, opposites when you're adding. So if I have like 7, the opposite of 7 is negative 7. And the reason for that is when you put them together, you get 0. Okay? And let's say if you had negative 12, the opposite of that is positive 12. And again, if you add those together, you should get 0. These are called additive inverse, more commonly maybe just known as inverses or opposites. Okay, so one of the things that we can do, this also, by the way, applies if you have like 5x, the opposite of that would be negative 5x, right? So if I add those together, I would still get 0x or 0, okay? So one of the things that we can do, and you're probably already familiar with this, you may just maybe didn't know it. Let's say I have 6, okay, and I subtract 6. Well, we know that that's 0, right? But let's say I have 6 minus, let's just keep it simple, 4. Okay, you go 2. Now, this problem I can actually rewrite as an addition problem. I can say 6 and then put a plus sign here and now write the opposite of 4, which is negative 4. And now if I add those together, I still get 2. So these two equations mean the same thing. So these two expressions, x minus 4 and x plus a negative 4, so subtracting is really the same as adding the opposite. And the reason that's important is because that's helpful for when we're adding and subtracting polynomials. We know how to add polynomials, or we can use this to subtract polynomials. So we're going to add the opposite with polynomials. So the opposite, you'll see what that means here in a second. And then you'll notice these steps are just the same as adding then. So if I just do this one extra step ahead of time first, then everything else will be the same, okay? So that's why it's kind of handy. All right, so how does this work? So add the opposite, that's what step 1 says. So what you're going to do is you are going to copy this first polynomial with the parentheses. Just like this. Okay. Now, everything after this parenthesis, now we are going to change the sign on. So we're going to change, we are going to set it, we are going to add. So we're going to now change this to an addition problem. In order to make that legal, we're going to add the opposite. So you're going to change the sign. Not only did you change this from a subtraction, but to an addition. The only way we can do that is if we change the sign on everything here. So that's the opposite. So this would become positive 5x squared, and this would become negative 9. So everything in purple, I've changed the signs on, okay? So now I can follow my steps that I had before. So now it's just drop the parentheses, combine like terms, and go from there, because now it's an addition problem. So what I'm going to do is you can erase the parentheses. I'm going to make this a little bit smaller so I can do my erasing. erase the parentheses, and then now I'm going to combine like terms. Okay, so combine like terms, step 3, and then make sure my answer is in standard form. Okay, so let's see. Let's start with x squared. So I've got negative 10x squared, and again, we make sure the sign goes with it, and a positive 5x squared. So negative 10 plus 5, use your calculator if you're not sure, that's negative 5x squared. I'm going to cross those out so I don't forget. And now I'm going to continue on down the line here. I've got negative 3x, and I don't see any others, so I'm just going to bring that one down. And then now I've got a 7 and a negative 9. So 7 minus 9 is negative 2. Okay, now my answer's in standard form, squared, then constant, or actually it's 2, 1, and then the constant, 0, right? Okay, so that's my answer, negative 5x squared minus 3x minus 2. And that's how you subtract polynomials. So add the opposite, that's the key first step. Okay, so let's try this. Let's try this again. Here we go. I'm going to copy the first. Okay, leave the parentheses in there for now. 7m to the 4th minus 2m squared. Now, again, I'll use the same colors here. I'm going to add the opposite. So add, and now this is the one people usually forget to change the sign on. It's easy to forget that one. Don't. Okay, that's a positive 5m to the 4th. This now needs to become negative 5m to the 4th plus 5m squared, and then minus 8. Notice I've changed the signs on all of these terms. Okay, so everything in purple, the sign has changed. And now I can get rid of my parentheses. Okay, and then we're going to combine like terms. So let's do it. All right, so start with my highest degree terms. I see 7m to the 4th and negative 5m to the 4th. I'm going to put those together. That's 2m to the 4th. Okay, and then it looks like the next highest degree term would be squares. So negative 2m squared. Again, keep that sign with it that's in front of it. So negative 2m squared and 5m squared would be positive 3m squared. And then it doesn't look like I have anything else. So this I can just bring down, minus 8. Don't forget to bring that down. I've got an extra plus sign hanging out. That's okay. Doesn't matter. And now there's my answer. It's in standard form. We're good. All right, it's a little better. So that's how you subtract polynomials. Use that to help you add the opposite first, and then the next 3 steps are the same. Okay. Here's a little bit trickier one. Go ahead and give it a try. See how you do. Pause the video here. Make sure it makes sense. All right. How did we do? Here's how this works. So I'm going to go ahead and I guess we'll continue with our color scheme here. And I'm going to add the opposite. So now this would become negative x squared. Don't forget that first one. Plus 5x to the 3rd minus 9 minus 11x squared. And then make sure that that's what you have as well. Okay, before you started combining. All right, so now I'm going to get rid of my parentheses. Okay, and we're going to combine like terms. So here we go. Let's see, x to the 3rd. I've got a 5x to the 3rd. It's the first one, so I don't need that plus sign in front. Then I'm going to do my squares. Okay, so squares, I got 9x squared. Remember, this is -1. If you want to put that 1 there, go for it. And -11. So I got 3. So I got 9 minus 1 is 8. And then minus 11 would be -3. So this would be -3x squared. Cross those out. I got a -3x. And I don't see any other x's, so just going to copy that. Cross it out. And then 7 and -9 is -2. So hopefully you got 5x to the third minus 3x squared minus 3x minus 2. And that is our answer. That's how we subtract polynomials. Hopefully you feel comfortable with that. Again, follow those steps and you should be fine. Okay, let's talk a little bit more about polynomials and what they look like. So here we want to first just use our graphing calculator to see what these look like. So you're going to use your graphing calculator to sketch the graph of each of these polynomials and then identify the number of real zeros. And we'll talk about what those are here in a second. But let's go to our calculator. We're going to type in this first equation, y equals 2x to the third minus 3x. So open up your calculator, and we want to graph something, so you're going to press the y equals button, and the function that we want is 2x to the third. So you're going to press the x button right there, and then to get it to the third power, you're going to go use this caret button on the right side in the middle. It's right above the division sign. You can see it highlighted in red, and then that will raise it up, and then you're just going to type what power you want. So to the third power. Now it's up higher now, so you're going to have to press the right arrow key to get it back, the cursor back down to normal level. And then you have minus 3x, so minus 3x. Okay, so 2x to the third minus 3x, and then you're going to press graph. Okay, so here, let's take a little closer look at this. Ooh, disappeared on me. Okay, all right, so here we go. This is our function. This is a cubic function. Now, a cubic function often has this little squiggle in the middle like that. And it can be more pronounced or less pronounced depending on what you're looking at. But this is really what you want to sketch, okay? So let's take a look and let's go back to our graph and we're going to sketch that. It doesn't have to be perfect. Just make it sure it looks pretty close to that. Now, if you are a fan of just taking a screenshot, which I kind of am, and then just pasting that in there, that's another thing that you can do. Okay. So let's go back and sketch this. Here's our graph. We're going to make a coordinate plane and sketch my graph. Okay, so now put some arrowheads on it. Now that's my graph. Now it says identify the number of real zeros. This is a fancy way of saying, so where is y equal to 0? That's where it hits the x-axis. This is really just a fancy way of saying how many real zeros are there. It's basically how many times it crosses the x-axis. So what I want to look at is where does it cross the x-axis and how many times? It crosses right here, it crosses right here, and it crosses right here. So it crosses 3 times. So the number of real zeros there are 3 of them, okay? And that's going to come into play a lot, especially as you get into pre-calculus. Those zeros are really important. Okay, so that's what a cubic function, notice is a cubic function. That's what a cubic function often looks like, is that squiggle. Okay, now you already know what a quadratic function looks like, right? It's a parabola, can open up or down. So you're familiar with quadratic functions already. We did a bunch of quadratics last unit. And this is what a cubic function looks like. So how about a quartic one, or in other words, a 1 to the 4th degree? All right, now notice this says f of x. Remember that just is the same thing as y. It's function notation for just y. So don't panic when you see that. It means the same thing. Could be k of x, could be y of x, could be lots of different things, but oftentimes you'll see f of x, g of x, whatever. Doesn't matter, that's just represents y. Okay, so let's go back to our calculator. We're going to type in that function that we saw there. Okay, and the function was negative. Make sure you use the negative button there, not the minus sign. Okay, so 0.1 x to the fourth power, so x to the fourth power, plus 2x squared. Whoops. Let's see. I'm going to delete that. And squared button is, you can use this as your squared button. It's in the middle on the left. And then minus 2. Okay, and now I'm going to hit graph. Okay, now this sort of looks like an M, right? So quartic functions often will look like this, like an M, or the other way around. They'll look kind of like a W. So I want to sketch that as best I can. So I'm going to take a closer look. It looks like this. Okay, and we're going to put that on our okay. And now I'm going to take one more look here. It's, all right, kind of weird. All right, so it kind of goes like that. All right, now how many times does it cross the x-axis? 1, 2, 3, 4. Now it will not, both of these happen to match this, right? This one has 4 and this one has 3. That will not always happen. So just be aware of that. So number of real zeros. There are 4 of them. Okay, and that's what a quartic function can look like. All right, so that is how we add, subtract, and then graph and talk about what zeros are. Write that into your planner. The assignment is adding, subtracting, and graphing polynomials worksheet. And then when you turn it in, don't forget to check it off. Good luck.